are doing, we are basically cloning given graph. So for instance, given graph like this, original graph, and it has to look exactly the same, just like this. So what we are going to do, of course, we will be traversing this original graph, and when we are traversing it, we will be creating this cloned graph. So every time when we are seeing this, let's say it's like this vertex, we start from 1, we'll clone it and then put it, and then when we are traversing it, the second one, we'll be seeing this one and connecting each other. So basically traversing it and creating new cloned one. So let's jump into coding. We could solve this one in BFS or DFS. Let's do DFS in this approach. So what we are going to do, we will have a map which will be where we'll be keep tracking of the original node to its cloned one. So we will be keep tracking if we have visited them and then create. So this original one right here points to cloned, and what we are going to do, we will be traversing it, this one, the original one, and on the way, we are keeping track if we have visited this one. On the way, we will be creating its cloned. Okay, so we'll call our DFS and then pass this node and visit it. Okay, and then this DFS will return us node, so we could just return node from here, and then let's check it. We are giving node first. Okay, now we will be recursively calling the CFS, so let's take care of base cases. So when node becomes null, then we'll just return node. And another case is if in visited contains key of this node. So let's say it's like we have visited everything and then we are coming back again, and then we have put 1 already in our map, and that means like we are seeing this one second time. So in that kind of cases, we don't want to end up in cycle, so we will just return this visited value, because it will contain, because this second one is a cloned one, so it will contain the cloned one. Okay, now let's create our node, which is cloned node. You can just say clone new node, and then what we are doing, so when we are seeing this one first time in this vertices, this node, we will be able to see its value as well, so we'll create a clone. Now we create a clone. Now into our map, visited map, we need to put this clone. So for given node, we are adding our clone. So now we created 1 and 1 in our visited, and the rest is we need to also for given node to find its neighbors, traverse through its neighbors as well. So for because neighbors, how are we accessing neighbors? Node neighbors, because like it has been defined the class node in here, and it contains neighbors, which is a list of node. So neighbors, and in there we could do for each. So what is this? It's a list of nodes. So node neighbor, in each of these neighbors, what we are going to do, we will be calling our DFS. So we can call DFS send this neighbor node to traverse it, and pass it to visited. So this will give us a node. So hmm, we can do inline. So we can just send this one visited. Uh, Not in visited. We are trying to add it to our clone. There we go. So whatever the thing comes up from here, um, like node and neighbors, we could just add it to our clone neighbors, which is a list. So add this given n, and in the end, we could just return clone. So let's run our code. Perfect. So let's submit it. Okay, so in this, the time complexity, what is the time complexity? The time complexity is OM plus N, M where it's all those vertices, N it's all those edges. Um, because we are seeing every of them once, and we are also traversing through its edges as well. And what is the space complexity? Space complexity is also OM plus N, where M is all those vertices, N is all those edges. On top of that, since we're using DFS, we have a calling stack. So OH, where H is the height of the calling stack. So overall, we can just say ON.